Okay, the masked professor is ready again. And today we will be looking at Chapter 15, Human-Computer Interaction. We are skipping to from 9 to 15 because it's kind of a more logical sequence to present the material. That's my story. I'm sticking to it like glue. All right. So, oh, bloody hell. I thought I was going to get away without having to read anything right away. But no, the horror. Chapter 11, Chapter 13, 14. Boy, I want to do 14. Oh, there we go. Human-computer interaction. Take one. First, I'm going to read the story at the beginning of the chapter. Ray Cox, a 33-year-old man, was visiting the East Texas Cancer Center for radiation treatment of a tumor in his shoulder. He had been in several times before and found that the sessions were pretty short and painless. He lay chest side down on the metal table. The technician rotated the table to the proper position and went down the hall to the control room. She entered commands into a computer keyboard for the PDP-2 that controlled the radiotherapy accelerator. There was a video camera in the treatment room with a television screen in the control room, but the monitor was not plugged in. The intercom was inoperative. However, Mary Beth viewed this as normal. She had used the controls for the radiation therapy dozens of times, and it was pretty simple. The Therac 25 radiation therapy machine had two different modes of operation. A high-power X-ray mode using 25 million electron volt capacity, and a relatively low power electron beam mode that could deliver about 200 rads to a very small spot in the body for cancer treatment. Ray Cox was to have the treatment using electron beam mode. Mary Beth pressed the X key for high power X-ray mode, and then realized that she had meant to enter E for electron beam mode. She quickly pressed the up and down arrow key to select the edit function. She then pressed the E key. The screen indicated she was in the electron beam mode. She pressed the return key to move the cursor to the bottom of the screen. All actions occurred within 8 seconds. When she pressed the B to fire the electron beam, Ray Cox felt an incredible pain as he received 25 million volts in his shoulder. In the control room, the computer screen displayed the message, Malfunction 54. Mary Beth reset the machine and pressed B. Screaming in pain, Ray Cox received a second high-powered proton beam. He died 4 months later of massive radiation poisoning. It turned out that similar accidents had happened at other treatment centers because of a flaw in the software. When the edit function was used very quickly to change the X-ray mode to electron beam mode, the machine displayed the correct mode but incorrectly delivered a proton beam of 25,000 rads with 25 million electron volts. This is a true story adapted from SKC, Set Phasers on Stun, and Other True Tales of Design, Technology, and Human Error. Could be an interesting one to read. Okay, so this chapter is about human-computer interaction. I have deleted or gone quickly over some sections because this book was originally written in 2004, and some of the information is not only out of date, it's way out of date. All right, so you saw in the initial story how using the computer had, far from making it easier to control the apparatus, had ended up causing Ray Cox's death. Increasingly, we're giving more computer control to many of the processes around us. Computers are constantly getting smaller, more powerful, and faster. When we talk about human factors and computers, it falls basically in three categories. The first of those is hardware design, where we want to maximize task performance and minimize ergonomic problems. The second is functionality of software. So, what the user can do with the software, the support or replacement of human effort using the software, and to automate tasks that were once performed by people. The third category is the design of the interface. That has to take into account the cognitive and perceptual abilities of humans, the application of the display principles that we learned in Chapter 8, the control principles that we learned in Chapter 9. All right, so what is the trouble with computers and software design? Well, part of it is that everything is changing rapidly and is very complex. That complexity often leads to a perception that things are difficult to use. Our software is often poorly designed so that our user performance suffers. There's confusion, panic, boredom, frustration, incomplete use of the system abandonment, modification of the task, compensatory actions, and misuse of the system can be the consequences from that. Our authors say that they don't see a systemic relationship between increased use of computers and productivity. All right, so we have some design criteria for usable software. And those usability criteria are efficiency, accuracy, learnability, memorability, and, of course, user satisfaction. Our criteria, we must remember, have more or less importance depending on the task and on the user. All right, so we have a software design cycle that they sum up as understand, design, and evaluate. We want to have involvement of typical users in that software design. So this is called participatory design. We want to then have different users, though, when we do our usability testing. So we want to use our guidelines and principles in the design. And of course, we've already seen many, many different guidelines and principles. And we want to do iterative usability testing starting early in the designing process. All right, so understand, design, and evaluate. Make it a bit larger. All right, there we go. All right, so we're understanding, and that leads to some things like error criticality, the use patterns, the goals, functions, and tasks, our user characteristics and expertise, the operating environment, our organization and culture in which our software or our computer equipment will be used. That goes then to design, and we say, okay, we have theoretical frameworks, computational models, mental models and metaphor, principles and guidelines, dialogue styles and standards. And a lot of that we will discuss, if we haven't before, in this chapter. When we evaluate, we use heuristic evaluation, usability tests and metrics, and test and evaluation. Okay, so you can see that then evaluation leads back into understanding. As soon as we have our initial concepts, we want to use some low fidelity mock-ups or prototypes and do some heuristic evaluations and usability tests, right? These are going to help us to know if we're on the right track, if we need to describe things differently, whatever needs to be fixed or understood better in designing our software. We should expect to have to go through many iterations to identify the useful functions and the user response to functions. When we get the design finalized, although what we think is finalized may not be finalized, we want to place our design in an operational environment. When we're there, we want to do comprehensive tests and evaluation. Again, expect many iterations. All right, so a big part of this is to understand the system and the user characteristics. So our functionality leads into the number and complexity of things the system can do. The greater the functionality, the more difficult that interface design is going to be. We call that trend creeping futurism. And we want to be careful, again, not to go over the number of functions that can reasonably be used. If we make a complex system and design that without taking into account our user attention, we're going to have a gap between our user and our user demands. That is going to depend more on our product characteristics. Whatever we make is often going to be part of a much larger system. And we need to keep in mind that how the system is going to be used is dependent on our organizational and social structures within a group. So a complex system requires a complex interface. We want to keep in mind the functionality and ease of use in our systems. So one thing is the frequency of our task performance. When we have frequency of use, that means that the user will invest more time in learning about a particular part of the functionality of the system. Mandatory versus discretionary use. Our discretionary users are going to use it somewhat frequently, but they will not be broadly knowledgeable. Our discretionary users are expert-like, but only on a small number of tasks. So when we have high frequency use, we need ease of use. When we have low frequency or intermittent use, we need to have ease of learning and remembering how to use things. Of course, all of this is affected by the knowledge level of the user. So our novice users know the task, but they have little or no knowledge of the system. So in that case, if we expect a lot of novice users, we want to focus on the ease of learning, low reliance on memory, using a restricted vocabulary, making the tasks easy to do, making error messages that are constructive and specific as to what the error is. And we have a list of technologies particularly designed for novices. First is icons. Icons are always very helpful. I'm willing to bet that every one of y'all has used a computer icon in the last 24 hours. Menus are very helpful, and we'll talk more about menus later. Short written instructions. If somebody is trying to do something, we don't want to confront them with 1,000 words that are closely written about the task. Very often we use what's called a GUI, a graphical user interface. That consists of having buttons, menus, windows, any other graphics that will allow intuitive use. All right, our knowledgeable intermittent users know the task, but they may have difficulty remembering the syntactic knowledge. In other words, what are the specific commands that get them the results they want? In that case, it is critical that we reduce the load on their memory, because they may not recall the specific actions needed. So the more we can point the way, the better off they're going to be. All right, then we have our expert frequent users. They have a deep knowledge of the tasks and goals, and they know the actions needed. Very often they like typing in the commands because it makes them feel in control and feeling like they're giving a good performance. The ease of learning and memorability is not as important for the experts. Right, they're going to have used the system often enough that they know all the shortcut commands, etc. All of this adds up. You know what? I'm going to go ahead and move that out there. So we need to have multiple paths to use by all the different levels, right? For our novices, have the icons, the GUIs. For the intermediate or intermittent users, we want to be sure that we have clear ways that they can get help and information when they've forgotten specific actions. And we want to have everything be easy enough for the experts that they'll be able to complete tasks quickly. So, one aspect of that is having an adaptive interface. Kind of the way that the Microsoft operating systems, I believe on the Microsoft 10, Windows 10 operating system, you can still have a view just like Windows 7, right? For those who hate to change or learn. We want to have clear guidelines for our user levels, but, not reality is more complex. It's not always easy to give those kind of clear guidelines. Modules. There you go, models. All right, so let's think about design using theories and models. In the book, they talk about the 7 stages of action, but the problem is they don't lay them out very clearly. So I've done the best I can to just adapt it to this presentation. All right, so our stages, the first bridge is our user starts with goals. Those goals are what to do to accomplish the task and how to do it. Those feed into the goals. Our second bridge is that our user processes and evaluates the feedback that he gets from the system about whether the goal is achieved and how well the goal was achieved. Oh, damn it, I'm moving that over. All right, so our stages, a user establishes a goal. The user identifies an action sequence to carry out the goal. When he does that, he translates the goals and his intentions into desired system events. But we have to remember the input device may make these actions difficult to carry out physically. All right, so well-designed systems will help us with what actions need to be carried out and what events and states result from user input. All right, so models of user performance for design include the GORMS acronym. The GORMS, this should be down here. GORMS stands for goals, operators, method, and selection rules. Our GORMS assumptions are that users will formulate their goals and their sub-goals. They will achieve these goals through methods and selection rules. So our method or sequence of steps is going to be perceptual, cognitive, and then motor operators, right? Any of our actions are going to have at least one of these in it. Selection rules identify our conditions for why we will use one method or a different method. GORMS can reveal problems such as we have too many methods to accomplish a goal. So that may result in users having used several different methods and not remembering any of them. When we have similar goals that are supported by inconsistent methods, that could be a problem. Consistency is extremely helpful in making anything happen here. And our methods relying too heavily on long-term memory, right? We don't want to put too great a load on our memory, whether it's working memory or long-term memory. All right, so there is a case study on page 394. 394. All right, so we have this case study. I noticed this case study, which I didn't see before, is from 1993. So what I would like you to do is to actually read through that on your own and I'll do something, possibly make the homework about Gorms. All right, one thing we want to do is we want to design to support mental models with conceptual models and metaphors. So bridging that gap between execution and evaluation is going to depend on the mental model. An effective mental model is going to be relatively complete and accurate and support our required tasks and subtasks, and allow the user to predict the results of the inputs or actions that they take. All right, the way we promote accurate mental models is by having good conceptual models. So we want to make the invisible parts or processes in the system visible to the user. We do that by providing feedback and building in consistency to the system. It's no good if you do an action one way one time, and then when you're doing something else, you do the same action, but in a different way. Very often we want to think very hard as to how we can present the functionality using a familiar metaphor. Metaphors are particularly powerful. So, for example, in Microsoft Word, or really the whole Microsoft suite, I believe, you can use cut and paste to remove parts or paste somewhere else. All right, so we always want to design using principles and guidelines. So we have some general usability guidelines here. We want a match between the system and the real world. As closely as possible, we want our system to mirror the real world and real actions. We want to stick with consistency and standards in the way that we build our interfaces. We want to have visibility of our system status built into our interface. We want to have user control and freedom. In other words, we can't have the interface just say, press the button at the bottom, right? People want to feel like they have more freedom than that. We want to be able to recover from our errors, prevent them when possible, or at the very least recognize that we have made an error. We want to keep in mind memory, particularly how few mental resources we have when we design. We need flexibility in our system and efficiency of use, and simplicity and aesthetic integrity. It's the old story of the motivational speaker. Somebody comes to him and says, hey, I want you to speak to the employees at my company. And the guy says, well, how long do you want me to speak? He said, well, if you want me to speak for 5 minutes, I need 2 weeks to prepare. If you want me to speak for an hour, I need a week to prepare. And if you want me to talk for 8 hours, I can start right now. Simplicity. Always go for simplicity of design. All right. I've spoken before about the tendency of designers to give our users a vast array of features and options. They want to meet every possible contingency, right? But we have to ask, what is this for, right? If it is for the expert user for professional use, that's one level of functionality. If it is for the non-professional user for home use, that should be much simpler. So when we put in too many features, we're doing more harm than good. We're just confusing the user. Designers forget that the users don't have the depth of knowledge of the system that they do. So they assume that what they know, the users can very easily learn, even though they've spent months or even years putting something together. All right, so for basic screen design, this goes into a little bit more from Chapter 8 on displays. Our interaction with a system is usually dependent on monitor screens. It is so much simpler to put everything on a monitor than to have hardwired gauges with switches and so on. So we want to focus heavily on the components and how we arrange those static screens with those components. if we use color, we need to remember the absolute judgment limits, design so that it could be understood if it's in black and white, right? And that is because of color blindness. And speaking of color blindness, there you go. Now it's spelled correctly. So we wanted to design so that color is a redundant feature of our display and not a major component that has to be perceived to understand what's going on. We always want to use light colors for the background. All right. So next we get into dialogue systems. First of all, there are menus. We want to use that as our dialogue style when our users have negative attitudes, low motivation. Hang on, let me capitalize. There you go. Poor typing skills, little computer experience, and little task experience. Each menu should have 4 to 6 items to reduce search time. So when we make a menu like that, we call that being broad but shallow. So we have many, many menus, but they all have just a few items in them. Sometimes we'll want to have menus with many items. We might want to do that with few levels with many items per level. Kind of our menu leads to other menus, leads to other menus idea. And we call that narrow and deep. For our menu guidelines, first of all, let's gray out inactive menu items. We want our menu items to be logical, distinctive from each other, and have mutually exclusive semantic categories, right? So in other words, I look here, I only have one menu that says file. I don't have one that says file 1 and one that says file 2. We want our labels to be brief and consistent in style, right? So we don't want one menu that has a one-word label and then another that has a 3-word label. Ways of ordering our menu choices are by convention, right? We already know many pieces of software, even just from casual use. So those have a convention, right? For example, the menu labels here on the word software. We want to order by frequency of use, the order of use, into functional groups, or alphabetically. Now, this is one of those guidelines where we want to use common sense. And we want to order our menu choices so that it makes the most sense by at least one of these categories. Okay, another thing to do in labeling menus, use the existing standards. File, edit, view. These are common on many of the applications that are already in use. All right, our second dialogue form is fill-in forms. Right? We have labeled spaces that we call fields that we're going to want our user to fill in. It's God for users with, wait a minute, not God, good. Good for users with a negative to neutral attitude, low motivation, and little system experience. We want it to reflect the content and the structure of the task that we're trying to accomplish. If it looks like a paper form, that's going to give familiarity that will help our users be able to do it more easily. All right, so our basic principles for fill-in forms: to organize groups of items with the task structure that we're trying to support. So you don't ask somebody their name, address, telephone number, a bunch of information like that, and then 47 questions later, what was your mother's maiden name? Use the white space on the forms and separate those logical groups, right? So maybe put a little box around a group and say demographic information or personal information. Then around the next group, and so on. Support forward and backward movement. You may only realize that you have answered a question incorrectly later down the line after you have answered some other questions. We want to keep all our related and interdependent items on the same screen. If it's a fill-in form, we'll talk about exceptions in a little bit. Indicate if the fields are optional. Our prompts need to be brief and unambiguous. And provide the user direct manipulation so that they can move through the fields easily on their own. Now, another way of doing kind of the same thing for dialogue is the question-answer format. In fact, I'm going to write down format, just to show them. All right, so you get here you get one question at a time, and the user types in an answer. All right, so we can use visual cues and white space to distinguish between our prompts, our questions, our input area, and our instructions. So, clear and simple language. So we don't say eschew obfuscation. We say keep it simple. We want to have flexible navigation again, the ability to go forward and backwards. And we want to minimize the amount of typing that has to be done. All right, another dialogue method is called command languages. This is good for users that have a positive attitude to computer use, so they have high motivation, medium to high typing skill, high computer literacy, and high task application experience. There are some cautions on syntax. Syntax, how do they keep track? No, sorry, that's an old Keith Laumer joke. We want our syntax, in other words, the precise way in which you have to give a command, to be natural and easy as possible. It has to be consistent. Again, we hit consistency over and over again. We want to avoid any kind of arbitrary punctuation. And use simple, consistent abbreviations. I remember the first Windows computers, you had to use a lot of command language, right? So if you wanted to pull up a program, you would have to type capital C, colon, and then it would be like / the name of the program. And if you got any of that wrong, the computer would say, "What the hell are you talking about?" Function keys are for the users who are performing our task frequently. They want more application speed, but they may have low typing skills. This is similar to what I talked about in Monday's lecture about multi-chord keyboards. All right, so we reserve function keys only for generic, very high frequency, important functions. We want groups of those tasks that should be, function keys that should be together, but only 3 or 4. And we want to base that arrangement on semantic relationships or task flow. We always want to label the keys clearly and distinctly, right? You may notice the keyboard on your computer, you have a whole row of keys that say F1, F2, F3, F4. Well, we still have those even though they're not as useful now. We want to label our keys clearly and distinctly. Distinct. I thought I put in an N there. All right, still no good. The high use function keys we want close to home road keys. The keys that have serious consequences if we accidentally hit them, we want to put those in hard to reach positions and not next to other function keys. Minimize the use of qualifier keys that must be pressed with other keys. So, for example, when I worked for Texas A&M, there was one function keys combination that we would use a lot, and that was Alt 0176, which, as you see, gives me the degree sign. All right, so then there are another kind of dialogue with the system is direct manipulation. So in that case, we're performing actions on visible objects. All right, so that maps well with mental models, and we have some guidelines here. We want to minimize semantic distance of the user goals and the required action. Now it occurs to me that y'all may not know what semantic means, or at least what it means in this instance. In this instance, what it means is the meaning of different actions as they relate one to the other. All right, so we want to choose a consistent icon design scheme, right? So you'll notice in the Microsoft Word, Excel, PowerPoint, all these ribbons are very similar in how they function and their arrangement. We want our icons to be concrete, to be familiar, but to be conceptually distinct. We want to accompany our icons with names if at all possible. For example, what do we call the symbol above the 2 on your keyboard? Right here we call it the @ symbol. In Israel they call it the strudel symbol. They actually just call it strudel. Symbol is understood. All right, so obviously this requires a strong understanding of the task that we are performing. We need high creativity to generate metaphors that make sense to help people develop a better mental model. Again, metaphors are very powerful in shaping people's mental models. And our last kind of dialogue with a computer is using natural language. Or in the book it talks about restricted natural language. All right, so in that, our users speak or write constrained set of language. And it's becoming more common. Oi, is it becoming more common? For example, today, you can pretty much just type a question into Google, and it will give you a pretty reasonable answer, where before you had to put something like coronavirus +, deaths +, US. assuming that that was what you're looking for. All right. Well, one thing that we have to have with these kinds of human-computer interactions is we have to have some kind of user support. The first example of this is software manuals. Typically, the users will never read that until they need help. I know I'm usually pretty careful about putting software manuals where I can find them, knowing that someday I will need help. We want to have the search words in the software manual be based on the goals and tasks of our system. We want to put our software manuals through usability testing the same as we do with the system itself. Increasingly, we're finding a situation where the manual is online, which may or may not be a good thing. It's great if everything's okay and you're and you just need a minor point cleared up. It's not so great if you don't have internet or you have a very complex problem. So let's look at table table 15.2. All right, so our guideline is make information easy to find. Well, they don't even give us an example. They figure that is so easy to understand. Let users' task guide the organization. So we want to base labeling, entry names, and sequencing on our user goals and tasks rather than on the system components. A poor example is upload file to server, access server data, and similar system labels. Better is base the labeling and entries on terms such as send letter, open mail. Our third guideline, include entry points that are easy to locate by browsing. All right, so a poor way of doing that is to have uniform blocks of text with no indication of content. Better, show each text section in boldface, the name of it, that is. Arrange the sections alphabetically, put the terms at the top of each page as headers. Use both table of contents and index. Use the system and user task terms like format, call out, button, and create a call out. And the book shows its age there because I'm saying, what the hell is a call out? Include entries based on both the system components and user goals and index both types of entries along with extensive synonyms at the back of the manual. When I was teaching engineering economy at Ohio University, one of the problems that my foreign students had was that there were so many different names for the same thing. And that would confuse them. And I would casually use things like investment and capital interchangeably. Sorry about that, foreign students. All right, so online help systems, it can be easy to find the information, but it can be context sensitive. In this usage, the users don't have to have space for their manuals. So if they work in a very small cubicle or they have a very cluttered desk, I'm not pointing any fingers, you understand. The information can be electronically updated, which can't be done with your print manual. It can be automated. A lot of dialogue systems that you interact with on the internet actually are automated. And they are so good that, for example, people start chatting with with a system at their nearby car dealership, right? And it'll say something like, "Hi, I'm Walter. How can I help you today?" You type in, "I want to look at Toyota pickups." Walter says, "Well, we have a wide variety. Is there a specific kind or a set of features that you want?" These systems are so good now that often people will show up at the car dealership and say they want to talk to Walter, and of course there is no Walter. And they'll get really mad and sometimes even leave, thinking that the car dealership is hiding something from them. All right, so what are some other problems? Well, the text may be difficult to read. That's obviously a problem. The pages may overlap with task information and interfere. So you may not be able to control the size of the window of your online help. The online help system may not have all the pages contained in the manual. I would say that's more an old problem. Now it is so easy to store information. Memory is so cheap that probably that is not as big a problem anymore. And of course the last problem is users are used to manuals. They may not understand well how to use an online help system. All right, so we can evaluate our systems with usability heuristics. um, that can identify the most relevant interface design principles that are related to the task. We want to be sure that we are applying our guidelines, principles, and heuristics properly, but have 2 to 4 experts evaluate the system independently. If we're all doing it gathered around a computer, it's not going to be as good as if each one does it separately and then we compare our results. We can evaluate our system with usability tests and metrics. We can use prototypes. There are different kinds of prototypes. One is what we call storyboards, where we have graphic depictions of our different system displays. We want to use low fidelity methods early because it's faster and easier to modify those if we discover we're going down the wrong path. The designers then are less invested in the work they've done, and they can change more easily. Not just change the idea of the interface or the system, but they can change their minds and allow that change more easily. When we get our users in and they're trying everything out, don't focus on the interface details. Get them to give you more substantive feedback about what they thought about the system. All right, so usability metrics. Y'all know that in some other classes, I stress the importance of using the correct metrics. You can easily use metrics that have nothing whatsoever to do with the task or with what you're trying to measure or prove. So we want to identify what we will measure. If we're testing for general usability, we're going to get kind of a qualitative assessment. The people use the system, then they say, I give it a 76, nice beat, easy to dance to. No, I'm sorry, that's from American Bandstand, which, as I think about it, may be a show none of you have ever heard of. Measuring user satisfaction is always a wise thing to do. We want to start, of course, with low fidelity. And when we do that, we won't get quantitative data collection, but talking with the users will give us valuable information about what they think about the system, how they think they would use it, how they think it should work, and so on. When we formalize the design more, then we're going to start collecting quantitative data about the effectiveness, about the efficiency, and subjective satisfaction of using the system. Our goal, we shouldn't forget, is to find a prototype that users like, they can learn easily, and they can use it successfully in performing tasks. So, one way we could do this is we can observe the users, either by standing over them with a clipboard and writing frantically, or by videotaping them. I suggest videotaping, it's less pressure. They'll quickly forget there's a camera there. You have to, as with work measurement, you have to reassure them to that this film is only going to be used to figure out how well they can use the system, how easy it is for them. Okay, so that can tell us difficulty with the controls, how hard it is to navigate the system, and give us some ideas about their general conceptual models that we're using in building the system and how that relates to a mental model. And then etc., always important. No, obviously I'm harassing you when I say that. Look, there are going to be other things going on. For example, if for some reason you have to stand there and take notes, or be there and take notes in any way, keep writing all the time. If they get to a certain part and you haven't been writing and you start writing, that brings the focus back to, oh my God, I'm being watched, right? So from the very beginning, you're writing things down. They may be nonsense. You may just be writing blather, 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 blather. Oh wait, he's having trouble with this part of the, right? All right, so table 15.3 on page 408, examples of software usability metrics with usability defined in a broad sense. All right, so it gives us some ways that we can have a usability metric. Under effectiveness, percent of the tasks completed, ratio of successes to failures, number of features or commands that were used, under efficiency, time to complete a task, time to learn, time spent on errors, percent or number of errors, frequency of help or documentation use, number of repetitions of failed commands. For user satisfaction, you can have a rating scale for the usefulness of the software, a rating scale for satisfaction with the functions and features, the number of times the user expresses frustration or dissatisfaction, the rating scale for user versus computer control of tasks, and perception that the software supports tasks as needed by the user. Words to live by. All right, so our next section is on the number of users and data interpretation. We want to identify specific problems with the software when we're looking at data. If we use, the more people we use, the more problems we will identify. But 5 to 6 people is optimal. If we do more, it may diminish the results, or it may give us too many false leads. They're saying that every evaluation and redesign cycle will enhance performance by 50%, which brings us to the figure 15.3. All right, so each of these dots represents a number of a trial, and then on the y-axis we have the benefit to cost ratio. You'll notice it peaks right around the number 5. So they're saying 5 user tests or evaluations is probably going to give us the best results. Now, if you're feeling like, boy, I'm still not sure that this has gone in the right direction, feel free to use more tests. All right, so what are our pitfalls of usability testing? Well, by itself, usability testing is not necessarily sufficient to guarantee effective software. Our prototypes may not be grounded in the understanding of users and human factors design principles. So we may be producing refinements of prototypes that are flawed already. They may not address the underlying problems, and all too often we see a situation where all usability testing is done in an artificial laboratory environment, and we don't see the problems that will surface in a more realistic environment. All right, the next part of this chapter is information technology, and you know what, there's some information that's useful in it, but enough of it is out of date that I'm kind of the mind that we should not even worry about it. Okay, so So that's what I consider all the useful parts of chapter 15. I hope that y'all are enjoying these lectures, or at least able to endure them without too much pain. And I am not sure what chapter I'm going to start with next Monday. I will think about that carefully. There are a lot of very enticing chapters, workplace stress, accidents and safety, transportation issues. It's a cornucopia of exciting things that we might be able to go into. Anyway, thanks again. Masked Professor out.